Hello, I am Dr. Jyotindra Mayavansi. Here today we are going to discuss about the aromaticity. So in aromaticity we will discuss whether your compound can be aromatic, anti-aromatic and non-aromatic. So to know the aromaticity of compound we need to understand certain rules such as what is the hybridization of the every atom in the ring, does compound contain 4n plus 2 pi electrons or not, and to decide that we need to understand how to decide which electrons are pi electrons. So for that, first we need to understand how to decide the hybridization. For deciding the hybridization, that you can see by this simple equation we can do it. So number of hybridized orbitals, that is equal to number of attached atom plus number of lone pairs. So in the case of methane, there you can see carbon atom is attached with the 4 hydrogens, so there are 4 attached atom plus there is no lone pair of electrons, so that's why it's a 0, so total it is 4, so it became sp3 hybridized. So in the case of water, there you can see oxygen is a central atom, so it is attached with the 2 hydrogen and there is 2 lone pair of electrons, so 2 plus 2 it is 4, so it is sp3 hybridized. So now, so how this is the way we can decide the hybridization. So for the hybridization we need to understand that we will consider a lone pair, not a single electron. So for in this case, there you can see 3 attached atom, that is why it's sp2. Here 3 attached atom plus 1 lone pair, so that is why it's sp3. And here 3 attached atom, but there is one single electron, so it's a free radical which will not be counted, so that is why it is sp2. So here carbon is doubly bonded, right? So that is why it's a sp hybridized carbon. Basis of hybridization, how the exception rule will work. So what is the exception rule? Exception rule is that if an atom has one or more lone pair of electron and it is attached with to a sp2 atom, then it is also considered as a sp2. So for that, let us see the example of this nitrogen. So as by the rule, if we will go, nitrogen is attached with this carbon and this is 2 hydrogen and 1 lone pair, so it should be sp3, but as our exception rule is saying that it has a 1 lone pair of electron and it is attached to a sp2 hybridized carbon, so that is why we will consider it is as sp2, right? So in many cases we will see later on, while deciding the aromaticity, we need to understand what is the hybridization of that particular atom, and in that case this exception rule will be very useful to us, right? So that we have to remember, if an atom having a lone pair and if it is attached to a sp2 hybridized carbon, then the hybridization of that particular atom will also consider it as a sp2. So as we know that when sp3 hybridization occurs, there will be a one s and 3p orbital which all combine together to form a sp3 hybridized orbital. There are total in 4. In case of sp2, there will be a 3 sp3 hybridized orbital and 1 p orbital will be left behind without participating into the hybridization. In the same case, in sp hybridization, there will be 2 sp hybridized orbital and there is a 2 p orbital left behind. So so when we will see a complete conjugation, so in that case we will see that when only sp2 and sp hybridization is there, then only we have a p orbital and the conjugation will become possible. In the case of sp3, the conjugation will not be. So how we will decide your compound is aromatic, anti-aromatic and non-aromatic? For that we have these are the criteria. For compound to become aromatic, it should be a flat, planar, completely conjugated, it should be a cyclic, right? So these two rules are common for aromatic and anti-aromatic. And the difference is that when a compound is aromatic, it should have 4n plus 2 pi electron, which is we called as a Huckel rule. So it should have 2, 6, 10 and 14 pi electron, whereas in anti-aromatic compound it should have 4, 8, 12 and 16. So these are 4n pi electrons. That is called as a anti-aromatic compound. And in case of non-aromatic, if compound is not following any of the criteria which is for the aromatic and anti-aromatic, so it will be considered as a non-aromatic non-aromatic compound. So it is if it is not flat, not cyclic, not completely conjugated, so it is non-aromatic. Now for to deciding conjugations, so we need to know a broader definition for conjugation. So earlier for the conjugation we consider it is as a when double bond, single bond, double bond, single bond. It is in an alternative way that is called a conjugation, but this is not the case. A new definition will be side to side overlap of p orbital at every atom in the ring. So how does it work? Let us see. So now in the case of this 1, 2, 3 and 4 compound which my cursor is moving, there you can see first is a benzene. So it is flat, cyclic and it is completely conjugated. In the case of second, now we have to see a hybridization like in the third case, in the fourth case, right? So in the case of first it is completely conjugated. In the case of second, what we need to do, whether it is completely conjugated or not, we have to see a hybridization. So here is double bonded compound, carbon, it is also double bonded, it is double bonded and it is a carbocation. So as earlier we had seen, a carbocation having a 3 attached atoms, so it is also sp2 hybridized. So here every atom is sp2 hybridized, so it has a p orbital present there, so overlapping is possible, conjugation is possible, and that is why it's a completely conjugated. Where in case of this compound number 3, there you can see here it is a sp3 hybridized carbon because it doesn't have any kind of lone pair, so it is not completely conjugated. And again in the case of 4, you can see it become completely conjugated due to the exceptional rule. What is the exception rule? If there is a lone pair and lone pair is attached with the sp2 hybridized carbon, then it is considered as a sp2. So now let us see, for there are few examples given below, whether they are aromatic or not. So for the first one, let us see. So it is sp2 hybridized, right? Every atom is here sp2 hybridized, so it is flat, cyclic, completely conjugated. Now the case is that we need to count the pi electrons. So how many pi electrons are there? 1, 2, 3, 4. 4 pi electrons, that's why it's an anti-aromatic. In the case of benzene, that is flat, cyclic and completely conjugated, so it has a 6 pi electron, aromatic. Now here is it has a sp3 hybridized carbon, non-aromatic compound. Now again this example we earlier had seen, so it is a negatively charged, lone pair will be there, every atom is sp2 hybridized, so it is completely conjugated. 1, 2, 3, 4, 5, 6 pi electrons, so it's aromatic. It is the pyrrole ring, so nitrogen having 2 lone pair and 1 lone pair, and nitrogen is sp2 hybridized, and the lone pair, it is in the p orbital, so 1, 2, 3, 4, 5, 6 pi electrons aromatic. So in the case of oxygen, that you can see oxygen is sp2 hybridized and it have a a 2 lone pair. So if you will see, out of the 2 lone pair, 1 lone pair will be the in the part of p orbital, so it will be participate into the conjugation, and the other one will be a part of sp2, because we earlier had seen that when there is sp2 hybridized carbon is there will be a 3 sp2 hybridized orbital and 1 p orbital. So 1 lone pair will be in the p orbital, so that is why it's become aromatic. So like this way, there is a few example is given here. So again, this lone pair will be not count because it is not into the p orbital. It will be in the hybridized orbital, which is sp2, and p orbital has already made this pi bond. So this double bond will not be count. So 1 2 3 4 5 6 pi electron aromatic, right? This is the cyclopropane ring. So again there is a 4 pi electron, 2 will come from this double bond and 2 electron from the lone pair, 4 pi electron. This is the smallest aromatic ring possible, that is 2 pi electrons aromatic, sp3 hybridized non-aromatic. So again 4 pi electrons anti-aromatic, 2 pi electron, and all the carbon is sp2 hybridized, so that is why it's aromatic, right? Here 6 pi electron aromatic, again 6 pi electron aromatic, 6 pi electron aromatic. So like this, basic fundamental principle, you can decide whether the compound is aromatic or non-aromatic. Thank you.